Hello, everyone. This is the ASME Dynamic Systems Control Division podcast series. I'm host Yama. In today's episode, we are very happy to have Professor Zhaojian Li from Michigan State University as our guest. So welcome, Zhaojian.
Thank you, Yo. Thanks for having me. And hello, DSCD podcast audience. It is a great pleasure to be here.
All right. Thank you again, Zhaojian, for joining this podcast series. And how about you start with a brief self-introduction first?
Sure. My name is Zhaojian Li, and I'm an assistant professor in the Department of Mechanical Engineering at Michigan State University. I got my PhD from the University of Michigan, Ann Arbor, in December 2015. And before joining MSU in August 2017, I worked as an algorithm engineer at General Motors, Milford, from January 2016 to August 2017. My current research interests are in the intersection of control theory and machine learning, as well as their applications to robotics and intelligent vehicles.
All right. Thank you for the introduction. So how about we start with some of your recent research work or highlight something you want to share with us that you're currently working on?
Yeah, sounds great. My recent research has been focused on mainly three directions. The first one is the cloud-assisted collaborative sensing and control for real-time privacy-sensitive multi-agent systems, where we systematically exploit cloud and onboard resources to enhance estimation and control performance of multiple agents while respecting their real-time and privacy constraints. For example, we developed a cloud-assisted collaborative road sensing framework where we employ iterative learning and Gaussian processes to iteratively improve the estimation performance of identifying important road conditions such as potholes and black ice. Another example is the cloud-assisted model predictive control framework, where we integrate a cloud-based nonlinear model predictive controller that exploits a high-fidelity nonlinear model because it can support. It has a lot of computation power to support nonlinear MPC, but it is subject to communication delays, and we integrate this with a local MPC that has timely state feedback, but it can only support a linear MPC due to limited onboard computation. So we developed the control fusion framework to enhance the control performance while we can also guarantee stability. And we also developed algorithm intrinsic privacy protection schemes to preserve privacy during cloud agent communications without affecting the control performance while preserving their privacy. And the second thrust I have been focusing on is field robotics, specifically on tree fruit harvesting robots. I have been collaborating with the U.S. Department of Agriculture in developing a tree fruit harvesting robot that can efficiently and robustly harvest the tree fruits such as apples, peaches, pears, and oranges. We have been developing the robot from scratch, and my students are actually testing our third version robot in the orchard right now. So hopefully we'll have some nice demo and results soon. Yeah. And the third framework I have been recently working on is the data-enabled predictive control, or DeepC, which is a framework that can control the system directly from input output data without the headache of developing and calibrating the complex models. So it is based on behavior theory, and it can be very useful for systems with complicated systems. So we have been working on some frameworks to address some of the challenges, including improving the computational efficiency and adaptability to novel situations. We have also utilized the framework in several applications, including the connected and automated vehicles in the mixed traffic scenario, as well as fast charging control for lithium batteries. And that's basically the major three research thrusts I've been working on.
Right. So as you mentioned, I think like the theoretical framework that you are describing can be applicable to many applications that you have mentioned, several of them, the robotics, the vehicles. And I'm just curious, like, what is your vision for, let's say, is there like a uniformed theme of all those fields that where you're seeing this as the three different thrusts are going forward, and what do you see as probably the most critical part that you want to solve together, like under this framework?
Yeah, this is a great question, and yeah, this may be related to some of my industrial background. So I typically would like to address problems that has industry relevance and close
Right.
to practical real problems. For this, for example, this cloud assisted control. So I have been working on that, collaborating with Ford on this project. How do we utilize cloud and multi-vehicles to enhance the controls and framework? And later on, after I joined academia, I actually kind of try to abstract the problem, right? It's not just for vehicles, but for general, let's say, multi-robot systems. So how can we, let's say we have a server, right? How can we utilize that, combine that with onboard resources, and to address time delays, real-time constraints, and privacy constraints as well. So make this more general framework, and it's practically very important issues to address. And for the field robotics problem, we definitely also want to make this practically viable and appealing to farmers. So it's not just research. We hope that we can make this robot very efficient so that the farmers would really be interested in using that. So to really have some practical impact.
Right.
And for this deep sea, right, this is a relatively new framework. We have been working on this problem and have identified some interesting fundamental problems as well as interesting applications. So for that, we have a few things to explore, and hopefully we can contribute to this fantastic framework and make this also more practically appealing to many industry applications.
Right. And I kind of have the same sentiment as you mentioned here. And speaking of that, since you have already worked in both the industries and academias for past years, so which leads to my next question. I think in the very recent the MAC conference we have just organized, I saw there are some very successful student-oriented sessions, the control careers in both academia and industry. So they organize these panels from experts from both fields to share some insights, particularly for students, I guess, considering that this is probably another wave of students are going to graduate. And so hopefully we'll give them more insights when they are making such decisions. So I'm just kind of curious, like to learn that, being that you have been into both fields, and could you share some of your thoughts and more interested, probably your personal opinions on what factors you considered when you make such decisions? And I think this probably be particularly beneficial for the early career professionals.
Yeah, thank you for the question. I'm so glad that the MAC 2022 has this kind of sessions. I think those will be very helpful for graduate students to think about, have some information to think about what are more suitable for their career. Yeah, as you mentioned, and I have been working industry and academia, and I think industry and academia are quite different. So to me, work in industry is more like accomplishing some predefined tasks and to deliver. This is very important in industry. We talk about the deliverables. So when we have meetings, always talk about deliverables, where you are in terms of the deliverables. While you will have more freedom to explore your research interest in academia. So that's the fantastic thing about working in academia. So you have a lot of freedom. You can write proposals about the ideas you are really passionate about, and hopefully you can bring funding, then you can hire students, work with the students. That's fantastic. But on the other hand, I think one can generally have better work-life balance if you work an industry job. As sometimes the pre-tenure faculties, we are in the same boat. I think we understand the situation. Sometimes the pre-tenure faculties can be very busy and stressful, and for a prolonged period of time. It's not just for there can be multiple kind of deadlines due almost at the same period of time. So it can be very busy and stressful. While I work at GM, right, definitely had much better work-life balance then. But yeah, I also enjoyed very much the freedom of doing research in academia. I have freedom to explore a lot of ideas I have. And for the question, like what are kind of the main factors to consider, I think first is that whether you are kind of interested in teaching and interacting with students.
Right.
I think that's very important because being a faculty is not just to do research, right? If your pure interest is just to research, you probably can go to like a research institute to mainly focus on research.
Right.
But right, as a faculty, you all will also have the opportunity to teach and to interact with students, mentor students, and grow with them. I think that's also a fantastic experience to me. So yeah, I think it's important to think about whether you like teaching and whether you like to interact with students. And also, I think important factor to consider is, let's say, at the point that you're gonna graduate or you're almost to graduate, whether you still have a few kind of ideas that you're really passionate about exploring, right? If you still have those kind of ideas you want to explore, I think it might be a great idea to try to apply for academia job and see whether you can land a position. Then you will have the freedom to explore these ideas and then grow from there. So I think those are the two kind of major factors I have in mind.
Right, and I totally agree with you, and I think the point that you mentioned that whether you have this idea that you have passion about is something that I don't hear quite often from other people discussion when we're talking about this particular choices, right? And so I totally agree with you on that. And whether you have something you want to make happen independently, I think going to the academia may be a better choice at that point.
Yes,
absolutely. Yeah, sounds great. Last thing I want to ask, this is probably from your website. I was very surprised to learn that you have worked as an air traffic controller, really?
Yes,
that sounds like such a cool job. I was share something more about us with us on that. How, and I just find my head spinning that you were an air traffic controller and years later that you switch both academically and professionally. Now you are a professor in the mechanical engineering and doing all kinds of cool research. And fill us in, what makes such a different choice of careers?
Yes, yeah, working as an air traffic controller was a very fun experience. So basically, yeah, I worked as an air traffic controller from I think 2010 to 2012.
Wow.
After I got my bachelor's at the Shanghai Aerial Control Center, which is one of the busiest air traffic control center in the world. So that work can be quite stressful at times. So sometimes you need to simultaneously monitor more than 20 aircrafts on the screen.
Wow.
And you need to send the commands to the pilots for instructions like climbing, descending, and making turns to avoid the conflicts, right? So you cannot going towards each other and having some close in-air kind of if it is too close, right, then will be issue and have a warning. So you have to constantly monitor the situation and come up with the ideas how do we kind of resolve the potential conflicts. So I think overall it was a great experience. I think yeah, this work experience basically trained me to stay calm and when under stressful circumstances because right, there are a lot of airplanes, a lot of the potential conflicts. You have to stay calm and resolve the conflicts.
Yeah.
And yeah, talking about the career change, I think yeah, it's kind of interesting. And yeah, there's a lot of randomness as well. So what happened was that after I worked as air traffic controller for 2 years, I want to kind of go outside and explore some other opportunities to see the bigger world. So I basically applied to a few universities. So I applied to University of Michigan Ann Arbor, the aerospace engineering. So there's a major direction called flight dynamics and control. So when I see flight dynamics and I see the flight control, I thought there at least will be some elements regarding air traffic control. But it turns out it's quite different. It's quite different. So it's more a lot of control theory. So then when I started the graduate school, I kind of struggled quite a bit in the beginning because I didn't take any undergraduate control courses. I directly started with the graduate courses, but it was fun. I think I had some good foundation in terms of the math, linear algebra, but I just didn't know some of the control techniques. The concepts. So, but after 1 or 2 semesters, I was able to kind of pick up those concepts and go from there. And again, this control theory is very fun, and I really enjoyed it. And then after I got my PhD, because I have been working with Ford during my PhD, and then I joined another automotive company after graduation. And then later on, I feel like I still have some research ideas I want to explore. So I chose to see whether I can find a position in academia. And thanks MSU for taking me. So I got the chance to explore some of the very interesting research ideas. So that's kind of what happened. A lot of randomness, but I mean, it's all a good and journey to me. Yeah.
Yeah, that was like more than 10 years ago, right?
Yeah, it's now 10 years. I have been in the US for 10 years. So I landed in Detroit Airport on August 5th, 2012. So
wow.
It's been 10 years. Yeah.
Now looking back, such a great adventure. I mean, the turn.
It is. Yeah.
Anyway, all right, Zhaojian, thank you very much for joining us for today's episode. I guess we're almost out of time, and thank you for a great conversation, and we look forward to seeing more of your exciting work in the future.
Okay, thank you so much, Yao.